Hello and welcome to the Type 1 YouTube channel. My name is Ray, and in this video, part 10 of MyRobotLab, we're going to take a look at the ADS1115 4-channel 16-bit analog input module that connects via I2C. So on this breadboard, it's hard to see it. This is it just here. I'm just going to pull it off the board if I can and bring it up. Let me just make that a little bit bigger for the moment. See if the auto zoom will work, auto focus even. So you can see that little tiny chip in there. That is our ADS1115. This is a 2 volt to 5 volt tolerant, 5.5 volt device, so we're 5 volt tolerant, and it works quite well for analog inputs. So I'm just plugging this in to the breadboard. On the breadboard I've configured 5 volt to it from the Arduino Nano I have over here. I've connected the ground. SCL and SCA are connected to A4 and A5, and ADDR, which sets the address, is connected to ground, which sets the address for 48 hex. Now the alert pin on this thing is an output, and you can use it to drive an interrupt to let your microcontroller or your computer know that it's finished doing a conversion if you're doing single shot. The way MyRobotLab uses it, we're not using that pin. And then we have our 4 analog inputs. Now I've wired one of my analog inputs up to the wiper of this potentiometer. This is a potentiometer I recovered out of a servo. And I've connected each side of the potentiometer up to 5 volt and ground respectively. Right, so that's the wiring side of things. Back over in MyRobotLab, let me just take my camera down a little bit. I have already set up the Arduino Nano. As you can see, it's connected via COM6 and it's currently online, and you can see there's a heartbeat running. So we want to actually connect that device, so we'll go to runtime. I'm just going to call ADS. The service is ADS1115. Now you can either hit tab or click on it with your mouse and start the service. We can go to ADS tab on the side here. That's the service we've just created. We're going to connect this to the Nano. With the Arduinos, all of the Arduinos, they only have the one I2C bus, so it's always 0. If you're running this on a Raspberry Pi, then you'll need to set 1. The address is 48, which is the default, so we're not going to change that. So now we've done all of that, we can attach, and this is now online. We've got 7 positive things here, so that's all good times from our Arduino, so I'm just going to get rid of those. And if we do a refresh, we can see that we've got about 3 volts coming in on channel 0. The information we get on these other channels is going to be garbage because it's not connected to anything. In theory, each time I refresh, there might be a few little differences in the numbers that we get, but they won't be really great. Most of that is noise within the wiring that I'm running. But if I turn this pot a little bit and do another read, you can see the voltage has dropped, and so is my ADC0 number. If I turn the pot the other way and refresh, you can see it's gone the other way. In fact, I can turn it all the way around, and you'll see I'm getting 4.668 volts, which gives us a count of 24,896. And if I turn it all the way back the other way, we'll get close to 0 volts with a count of 4. And there's 2.466 volts. So these are a really good device if you need to have analog inputs down where you've got an I2C bus already. So in Fred's hand, or Fred's left arm, I have a PCA 9685, which is I2C driven device, to give me 16 servo channels. I can add one of these in to give me 4 analog channels. With the address line, tying it to 0 sets the address at 48, but if I tie the address, it's not going to let me do that while I'm attached. If I set the address line to positive 5 volts, that'll give me address 49. If I tie it to SCL, it'll give me address 4A, and if I tie it to SDA, it'll give me address 4B. Now all this information is available on the datasheet for the ADS1115. Now in MyRobotLab's website, they do have some more information on it. To find that, let's go to the menu. Actually, let's move my camera so you can see the menu. So if we go to the menu, go to documentation. If we scroll down to get to service matrix, this is a list of every service on MyRobotLab. Not all of them are working. Some are outdated, but the vast majority are pretty good. Alright, so the ADS1115 is up here near the top. And it tells you here that it's a 4-channel analog digital converter that you can communicate with using I2C. This means that you can connect this directly to a Raspberry Pi and use the I2C bus on the Raspberry Pi GPIO. Now I don't think this has been updated in a very long time, but that connection diagram is actually very good. I think it was originally created by Mats, but I could be wrong on that. But yeah, it works quite well. There is an example, I think this is an old example of how to run the ADS115 or 1115. Did he actually connect the address line? Yes, he did. He connected the address line to ground, as I did. And it lets you call the refresh and then read off the values, which is what we were doing essentially on the web GUI. As with all of the service pages, there is a JavaDoc link. If we go to the JavaDoc, you'll see a little bit more information on what information is available. So we can actually read the voltages. And here's a list of the commands. So apply is to do with service config, attach, detach, disable, enable, get pin, and we've got the more useful information. So we can actually read a pin. It'll give us an int, and we can actually set the address. So if you're going to actually start this up using code in Python, you need to set the address, you need to set the bus, and you need to set the controller. Then you can attach. So yeah, it's all pretty straightforward in there. It is a very simple service to use. As you can see, we just supply it with an analog input. Now we can use any analog voltage coming in from 0 to whatever the supply voltage is. So 2 examples, other than using a pot for inputs, you can actually use a Hall effect sensor such as the AH3505. I think it's a 3505. Yep, 3503, sorry. So let me just get that up. So this AH3503 is a linear Hall effect sensor. We can run it up to 6 volt supply or down to 4.5 volts, so it works well with an Arduino, and or with a 5 volt supply. So in Fred's left hand, I've built the version 2 hand from the InMove website as created by Gail Langman. And with that one, we have in the finger sensors, we have little magnets embedded in the tips of the fingers, and that pushes, it's mostly hollow or soft in there, and as it touches, it pushes in and moves the magnet closer to the sensor. We see that as an increase or a decrease in the voltage to the Hall effect sensor, which I can then read with one of these channels. So it works quite well. The other thing we can do is we can measure temperature. So what we can do is get a NTC thermistor, similar to what we use in our 3D printers. So that's just a set of wires. I don't have one handy on my desk. They are around about 100 ohms in resistance. So if we get a 100k ohm resistance, which varies with temperature. If we get a 100k ohm resistor, put them in series, and in that connection point, take that back to our analog input, put one side of our 2 resistors, essentially, one to ground and one to 5 volt, we can actually measure the voltage of the junction. As you heat up that junction, that voltage will change slightly, and you can actually calibrate that to give you degrees in Celsius or in Fahrenheit. So that's 3 different uses. We can use it to measure the position of a sensor, such as a pot, or a Hall effect sensor, or a NTC temperature sensor.
Okay, that'll do for this video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell so you're notified when other videos come out. It's also a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account, and you can join my VIPs Go Lucky and Lorenz Berger, as well as my Builder Patreon Almorales45. You'll find a link in the description below. I also have a Discord channel. You can talk to either Fred or myself or one of the other members of our growing community. You'll find a link in the description below. And we'll see you in the next video.